Usually during the lab demonstrations, I will switch off my video, so there is no need. That's why I just, so that you can see the practical work. Okay, so Wireshark, it comes by default with the Kali Linux. You can also have the Windows version. If you're working on Windows, you can download and install it on your Windows operating system as well. So if I just write Wireshark here, so you can see that it comes with the Kali Linux. So it's just simply, it's a GUI based application. And so once it starts, so you will see this kind of interface, right? So what it means is that you can start capturing right from here. You have to give the interface on which you want to capture. So I have ETH0 interface, local loopback, Bluetooth, and all these. So some of these interface, they don't really exist on my machine, but or maybe, for example, some of them, they might have no traffic going on them. So once you download and install this on your host operating system, you will see that it will also show you your wireless interface. Because I'm running in a virtual machine, so there's no wireless interface that you can actually see. And then you can see these small bars on some of these interfaces. What it means is that there is some kind of traffic going on. So once I boot up my virtual machine, since it is connected to the internet, there are some packets which, the machine automatically keeps on sending. Might be the ARP packets, for instance. So either you can, if you know which interface you want to choose on which the traffic is going on, so you can choose it from here. Otherwise, if you just click any, it will start capturing, all the interfaces. So because I know that my Kali Linux, it has a ETH interface, which is the Ethernet interface. So if I just write ifconfig, so these are the two main interfaces which are available on my Kali Linux. There is ETH0, the Ethernet interface, and then it has a local loopback. So because the traffic is going on in ETH0, so I'm just going to choose this interface so that I can start capturing the packet. Now, as soon as I start the capture, you can see that my machine has already started capturing packets. Although I'm not doing any activity myself, I'm not opening the browser or I'm not sending any certain packets, but there are some packets which are auto-generated. Like you can see some of the type of UDP packets which are going here. There are, like I told you, ARP packets are going on the network. So what we want to do in this particular lab is that you have to analyze some of the packets. By analyze, I don't mean like you really need to go deep into the packet, but we want to see what kind of packets does Wireshark capture, and then how we can filter them if we are looking for certain packets. Imagine that you are capturing a packet on the network, and then somebody is using an insecure web page, which requires a username and password. So that username and password will come here in the clear text. Nowadays, we know that HTTP is no longer being used. Maybe there are some organizations which are still using it internally. So in that network, if somebody is logging on to the insecure web page, then obviously you can see the username passwords here. But if somebody is using HTTPS, you can still capture the packets, but you won't be able to see their credentials because they will be encrypted, right? So let me just go ahead and, for example, if I go to the browser and open it, my machine is acting quite slow. Okay. So for example, if I just go to Yahoo, for instance. So you can see that I have sent an HTTP request, right? So if I want to analyze or see when I sent this request, what kind of packets got generated, you can see there's a lot of packets flowing now through my machine, and the the Wireshark is actually capturing all of them. And you can see now that the protocols TCP and TLS are being captured by the machine. So if I stop here, for instance, and I start looking, for example, I'm looking for the HTTP packets only that I just generated. So if you see here, it says there's an HTTP packet. So what you see in this window is that the timestamp at which it captured the packet, and then the source IP address, okay, and then the destination IP address. So source IP is this one, destination IP is some external web server, and it's sending the HTTP request. Now, it also captured some of the OCSP protocol as well. Let me see if it's using HTTP version 2. Okay, HTTP version 3. No. Okay, so the HTTP packets are only like a couple of packets, but did I actually send the HTTP request or HTTPS request? Guys, when I open the Yahoo page, did I send an HTTP request or HTTPS request?
S.
I think S. Yeah.
Yes.
S.
So for HTTPS, for instance, I can first write the TCP. And all these packets that you see that are using TLS version 1.3, they are basically the HTTPS request that I just sent now, right? So, or the alternate way is that you can also search it through the port number. So if, for example, HTTP uses port 80, I can look for port 80. If you're using HTTPS, I can start looking by using the port number 443 as well, right? So if you see here, the protocol, usually the HTTPS or HTTP protocol, they start with the TCP handshake. I don't know if you have studied the handshake. So when you make a request to the web server that I'm looking for a page, www.yahoo.com, before your request goes, your machine is going to establish a handshake. So this TCP handshake is essentially, there are 3 packets which are sent. The first packet is actually the synchronization request, which, as you can see here, it's a SYN packet or synchronization packet. The second packet comes back from the server saying that, okay, I acknowledge. So you see it's SYNAC. And the last packet goes again from your machine. Acknowledgement. So first of all, in the HTTP or HTTPS, the 3-way handshake takes place. So basically what I'm trying to show you here is that when I made the request to the Yahoo server, first the handshake was done. And after the handshake, then the client hello message is going, and then you can see now that the port number here is also 443, which means that the HTTPS communication is going to start. So here, for example, it's a TLS client hello. If I open any packet, for example, let me just start with the first one. If I open this packet, double click, you can actually look into the details of the packet, right? So it's a TCP packet, so I'm just going to expand this one and show you what kind of information you can get from a packet. So here, for instance, it shows that the source port number is 43346. So remember, when you are making, you're establishing an HTTP or HTTPS connection or any other, the source port usually number is, picked by the system itself, and the socket is created. So there are basically 65,536 ports actually. So you can see here that the source port is kind of a random port. And then the destination port, because I wanted to because I requested HTTPS. So basically what it means is that I'm sending a request on port 443 of the destination, right? And then you can scroll down and see a lot of other information, which at this stage, you don't really need to go into all the details of the segments and the segment length and so on. But imagine if this was a packet which was containing the clear text username password, then obviously when you come to the data field of this packet, you will be able to see the username and password. If I open the TLS packet, the client hello packet, for instance, now you can see here that destination port obviously is supposed to be 443. And then here you can see that this is the conversion TCP length segment. Let me just scroll down. So this is the TLS security. So here you can see that it's using TLS version 1.3. So there are different versions of TLS depending upon your browser, how old it is. It might be using some older version of the TLS protocol as well. Okay, so what you need to do today is that not only that HTTP you have to analyze. Okay, before I move on, now another thing that you can do is like what I did, for example, was that I just looked for the TCP packets, for instance. But maybe you want to look for a certain source only. So you can see that there are different source IPs coming here, based on the request and response. But if I want to look for the packets in which the source is 13.33.60.68, so I just want to filter out the packets in which the source IP. Okay, before I go into the source IP, you can search it on the basis of IP, which means whether it comes in the source IP or whether it comes in the destination IP. You can mention the IP here. So for instance, I'm looking for the packets which contains the IP address 13.33.60.68, for instance, right? So it is going to remove all the other packets, and it will only contain the packets in which either the source address is 13.33.60.68, or it will show you the packets in which the destination IP is there. So either of the source and destination, you can see in all the packets, it's the IP address that I put it here, right? Is this clear, guys?
Yes.
Okay.
Yes,
That's
okay.
clear.
So you can also search it by using the, so the filters, most of the time when you write a keyword, for example, they pop up that like what kind of filter you want to use. So for IPv6, for instance, you have to use this filter, IPv6.address equal to, and then you give the IP address here, right? And then IP dot source, I think the filter, yeah. So as you can see here, that you can also find it on the basis of the source address. So what does it mean? It means I want to look for the packets in which the source is this one. So it is going to remove all the other packets which have a different source IP address. So I think, if I'm not wrong, IP.source equal to 192.168. Sorry, I was looking at 13.33.60.68, right? So now you can see that in all the packets, the source IP address is 13.33.60.68. So this way, by using the filters, you can actually filter the type of packets that you are looking for. And now I can only see wherever the source is this IP address, I can go ahead and start looking into the packets and see, look for the information that I want. Okay. Now the lab task for today is that you need to run Wireshark, and then you need to analyze some of the protocol. By analyze means like you can use these filters and look for the packets. So for example, what you can do for today's lab is that I will open the command shell, and then, like for example, can anyone tell me which protocol is used in the ping request? So if you want to restart it, I can go to capture. I can start again and continue without saving. If you want to save the pcap file, you can always save it. For now, I'm just skipping this part. So can anyone tell me that which protocol is used for,
I said TCP.
no, when you send a ping request. So I say ping google.com, for example. So which protocol will be used in a ping request? Anybody?
AT?
TCB?
Have
I
you heard of have you heard of ICMP protocol?
yeah, I believe it's used ICMP, but use like random ports, they said.
Yeah, but the protocol, because I'm talking about the protocol, the type of protocol. So remember, whenever you make a ping request, it is always going to use an ICMP, Internet Controlled Message Protocol. And basically, the purpose of this protocol is that you just want to check the connectivity. So I don't know why it's not, it didn't work. I mean, it didn't start capturing. So let me try to do it again. Okay, so you can see here that when I'm sending the ping request, it's actually capturing the ICMP packet. If I just stop the capture here and I go to ICMP, so you can see that all the ICMP request and reply. So ICMP works in a way that you send a request to the target machine, and the target host or machine is going to reply back that, whether it's alive or not. And then for your own knowledge, you can open the ICMP packet and you can try to look into the type of information that is available here. Okay. Now for the lab, coming back to what you have to do. We did work on the Nmap, right? So what you need to do for today's lab is that you need to use at least 3 different switches. Like, for example, you can write nmap -st and then give the target IP address, whatever it is, 192.168.36.1, for example. So you can send this request to your gateway, for example, and then see the wireless router, wherever you want to, the host, you can write it. So the reason I'm asking you use 3 different options, because when you write -st, it is basically a TCP SYN scan. So you will see the synchronization packets going, from your machine towards the target machine. Similarly, if you are going to use, for instance, -SN, it's basically a null scan. So you will see that the type of request being generated from your Nmap is going to be different from the previous one. If I write it -SU, for instance, it's going to send the UDP requests, I guess. So how you can find all these switches, I told you guys that in Kali Linux, you can look for, I'm sorry. You can look for the help for the tool, but it's just typing -help. So now you can see here that you have all the options of the Nmap. So what I want from you guys is that use 2 to at least minimum 3 options or 3 different scanning techniques which are mentioned here. So like I said, if I write -SS, it is a half open scan. I think that's what they call it. You can also call it a SYN scan. ST is a TCP connect scan. Sorry, I said SYN scan in ST. It's a TCP connect scan. If you write -SA, it will be an acknowledgement scan, and so on. So, and then if you put -SU, it will be a UDP scan. If you write -SN, it is a TCP null scan. If you write -SF, it is a FIN scan. So what I want from you is only you can choose any of these 3 options with -SS, -ST, -SU, -SN. So all the students, they are free to choose whichever option. And then just when you capture the packet, just compare the type of requests that are going from Nmap, and you can view them here in the Wireshark, that when I wrote -SN, what's the difference between -SN and -SS, for instance, right? It's not a difficult lab. It's just that we want you to get comfortable with the Wireshark and then try to see what kind of packets are being captured when there is Nmap scanning going on the network, right? So let me just do one for you quickly. So I hope it starts again. I usually don't use it. Okay, it already started capturing a lot of packets, but anyways. So let me see and go back.
Do I always have to restart it when I use a
No,
different
no, no,
tool?
no, no. Now I didn't restart it. Last time there was some problem that, yeah, like for example, if I stop here now, okay, I already have the capture is stopped, right? So if you want to start a new scan, like I want to start a new scan now, I have to go to capture and then start it. If you do not stop it, it's fine then. I mean, if it is already capturing, for example, and then you start the Nmap scan, it's still fine. I just stop it so that I can have less number of packets. And then I told you that once you want to close it, for example, or you even if you want to save it, you can always save the packets, right? So for example, if I try to close it, it will ask me, do you want to stop and save the packets? It is going to save the PCAP file, which will have all the packets. So let me just start and give you an example of an Nmap scan. So 36.128 is the, let's say, IP of my machine. I'm going to just send, I'm going to target my gateway, for example, 36.1, sorry. So Nmap, in this case, for example, I'm just going to use a UDP scan and start. So if you see here, it clearly shows that the UDP protocol is being used when I'm performing. So there are lots of UDP packets going on, right? Along with that, there's ICMP also, you know, that is, so what you need to do is that once you stop, you will take the screenshot, and then when you run another scan by using another option, you will again go and see what's the difference. And you can even go and try to see basically what is going on, what is the source port, what is the destination port, for instance, and things like that. And
So
obviously,
basically, we will use Nmap command,
yeah,
and we will go to Wireshark to see
yeah,
how it's going there.
exactly, yeah.
Gotcha.
Actually, you can capture any protocol. You know, for instance, if I telnet a router, you know, when you telnet the router, it asks you for the username and password for the login, right? You basically want to gain access. So telnet is an insecure protocol. So if somebody is using telnet on the network, and you are basically capturing the packets at that time, obviously the username passwords will go in the clear text, and you will be able to capture them. The idea here is not that Wireshark, you are going to use it to capture username and passwords on the network. The idea is that it's a very powerful tool for security, for network administrators. It is used for troubleshooting, even for the research, they use it a lot. So I want you to explore the tool a little bit in this, you know, first lab, and try to see what kind of packets are going on, try to look into the headers of the packet and see what kind of information is there. Right, guys?
So, Mr. Asad,
Yeah.
the Wireshark tool is basically to, as you mentioned, to see or oversee the connectivities happening right now. I can't apply it on something happened on the past, for example.
Of course you can. I mean, if you have the PCAP file or the capture files of the packets from the past, you can go ahead and go to the file and then open. If the file is there, that's something that happened on the past, and you have the capture file, you need to have the capture file. You get my point? So if there is no capture file, obviously you cannot analyze them or you cannot see them. So unless you have, and by the way, on the internet, you can see so many PCAP files. In fact, there are several websites which have the sample PCAP files. Like for example, I will give you example. So I think a week ago, I was trying to look into the SMTP protocol. And, you know, when you are, so SMTP is basically the simple mail transfer protocol, okay? Email transfer protocol. So what happens is that I wanted to analyze the SMTP packets and the headers, and I wanted to see like what kind of information is in the header of the SMTP protocol. So when I opened my machine and I was using this web client for email, which is, Google Chrome. So what happens is that the SMTP protocol, basically on top of it, we have the HTTPS is running, and HTTPS is encrypting everything. So I was not able to see any kind of communication or not able to find the SMTP packets. Usually, by the way, SMTP works between the servers, between the email servers, unless you have a client, for example, installed on your machine. So I said, okay, where can I find the SMTP traffic, or where can I find it? So what I went and I did was that I just Googled that, okay, I'm looking for SMTP sample PCAP file. Okay, so the internet is full of all these Wireshark files. So you can see here that you can get the SMTP, traffic, PCAP files, and you can simply go ahead and open them. I don't know if this link actually contains the one that I opened, but if you want, I can show you the PCAP file that I downloaded. And just a minute, let me pull the file that I downloaded last time, rather than wasting time and looking, so that I can show you. Yeah, there it is. So, and this way you will also learn, like if you have a PCAP file from the past, you can open it still, right? So this is the SMTP PCAP file that I downloaded somewhere from the internet. You can either double click it directly because it's a PCAP file, so automatically it will open, or you can go to the file and open it, right? So now you can see that if I want to analyze a certain protocol like SMTP, I can see that there are, so I can write only to SMTP. So this is actually what I was looking for. So if you see here in this particular example, so usually how the SMTP works is that there is a hello, hi messages exchange between the client, SMTP client and server. And you can also see here there's an authentication login information going on between the client and server. And you can really see here the user name and the password as well, although they are encoded. So this is the username, okay? As you can see here, if I can open it and I can show you here, this is the username. And since it is not secure, you can actually easily decode it. If you know how it is encoded, you can actually Google like what type of encoding is done in the SMTP protocol. So this is not an encrypted password, okay? It is a simple encoded password. So it can be decoded easily. Sorry, username. And then here is the password, for example. So I can just go online and see what kind of encoding technique is using the SMTP. So this is a clear text password, in other words. This is what I'm trying to say here. So anyways, rather than going into the detail of the SMTP protocol, let's just go back to what you have to do. So what you have to do is start the Wireshark, start the Nmap, and try to run 3 different types of scans in the Nmap and then compare them. What's the difference? Put your screenshots and give like a small description of 1 or 2 lines for each of these screenshots, that what difference did you find between them? Yeah, so for today's lab, this is enough for this submission. And then we are going to share another lab with you guys, which is related to the packet tracer, which basically you will do it on your own. So I'm not going to give you a demo for the lab. Let me see if I can grab the, yeah.
Should you download the bucket tracer?
If you do not have a packet tracer, you should download it and then install it. Only then you
in
will.
Windows or Kali?
In Kali, the packet tracer, I don't think it will work, and there's I don't think it even exists for the Kali Linux. So it will only work on the Windows machine. Okay.
Okay.
But those who are using Mac, so they have a Mac version as well. So no worries. Okay. Let me see. So guys, the lab is clear now. What you guys have to do?
Yes, clear.
Okay.
Yes.
So okay. So I'm actually looking for the PCAP file. Copy link to the file. Okay. All right, so let me just try to log into the packet tracer file and explain you what you guys need to do. Can you guys still see my screen?
Yes.
Okay, I'm going to stop sharing that and then I will share the packet tracer window, or let me just share the whole screen. Okay. So basically, this is what you guys have studied today. I think you guys have studied the radius protocol, right? Right, guys? Or Kerberos, or both? Which one you studied?
We did like both, but we did not talk really about the Kerberos one because was like the meeting. He says we're gonna continue with that later, and he did show us this one, and we did like the AAA for Cisco one. This one, I believe so. Yeah.
Okay.
Yeah, we just got a hint, so it's
Okay.
not compromised all the way.
All right. All right. So basically, it's you guys know what is AAA and authentication, authorization, and auditing. So the protocols that you have, like Radius and TAC ACS Plus, or Kerberos, for example, they are providing you with the AAA services. TAC ACS is a Cisco proprietary protocol. Radius is an open protocol. And they both are very popular and used, and even the Kerberos, is used as a single sign-on protocol. I don't know. I don't think I will discuss the topic itself because you're already covering it in the morning. But you can do it in the packet tracer. Actually, if you want to install the Radius or the TAC ACS, the actual way is that you need a server machine, like a server 2000. 2022 or 2020 or even 2003 or whatever server machine you have, and you can really install, and it's like really easy in the Windows to install the Radius or TAC ACS. And once you set up your Radius server, so you can even try at home. I mean, when you are free in your free time, then if you're interested, I can share you the lab manual that how you can install the Radius on a virtual server and try to see how it works, right? But for today's lab, I think Mr. Shadi has already explained this lab to you, that what you guys need to do, right? So when you complete your activity, it is going to show you the progress, how much you have completed, I think, somewhere here, right? So whatever you can complete, just try to complete it and submit a message. I don't know, there is a submission link Mr. Shadi has shared with you where you need to submit the packet tracer file, or no?
No, he says he's gonna share it in Discord later.
Okay.
I know when, but he says he's gonna share that, and it's gonna be optional, I believe, so, or something like this. I'm not really sure.
It's optional. I mean, we're not going to consider it as part of the today's submission, but this is to keep you interested, relevant to the topic, so you can try to learn how to configure the AAA. The commands are mostly given, I think, in this packet tracer file. If you feel any problem in completing it, you can also search on Google, because the activity is 3.6.1.2. So you can just write in Google solution for 3.6.1.2, just in case if you need help and you're not able to complete the activity. So the idea here is that you should learn how to complete it, right? So try to complete this activity once you're done with the first lab, and then on the platform, you will not submit anything related to the packet tracer. You will only submit the Wireshark. Okay. So here it shows how much you have done and how much is remaining. So when you click on this, it will show you which part is done, which part is not done, right? So all these cross means that nothing is done. It's a blank file. Okay, guys, I think I'm done from my side as far as the demonstration is concerned. If you guys have any questions, please ask me now, or you can start working on the labs.
So, Mr. If we try to install packet tracer, we work directly on our Windows, or we should download Windows Server on the VMware machine?
No. There's no need to download server or anything.
Okay.
That was another activity that I was talking about, that whenever you have free time, not today, because the
Yeah.
server downloading and server installation and then domain setup and then radius installation will take a lot of time.
Yes.
Whenever you are free, I will provide you with the whole lab manual where you can learn how you can set up a domain name server, how you can install the Active Directory, how you can configure the radius protocol. So that is something I was talking about for later. Today, in order to complete this lab, you need Packet Tracer. And Packet Tracer, you can just download it from the internet. It's free from Cisco. Okay.
Okay.
All right. Thank you.
So
Okay.
that
Yeah, please. Let me stop the recording first, please.